Hey, and welcome back to part 2 of Law of Cosines. But this really isn't really the Law of Cosines. This is going to be about bearings. And what I really want you to notice, or you may have noticed, is that we're not going to be talking about areas of a triangle, which is the next section in your notes. We'll talk about that in class. So if you can do me a favor, flip over to the next page or the last page of your notes, and we're going to talk about bearings. And you may be asking, what are bearings? If you're a skateboarder, you may think of bearings as the little ball bearings that are inside of there. That is true. But in pre-calculus, we talk about bearings as a way of telling direction. Now, you may be familiar with north, south, east, west, okay? But with bearings, what they do is there's two types. You have one, this is called a compass bearing. In a compass bearing, they do talk about north, south, east, and west, but in a slightly different way. And so what I want to do is you already have the pictures already drawn out. I want you to follow along and show you how I'm drawing these pictures. Okay. So it's here in a compass bearing. All bearings are measured from the north or from the south in an acute angle to the east or west. What does that mean? It says when I do a compass bearing of B from A is north 35. So you guys have this up here. Oops. So what I do is I first start off by saying, so I want to do the take two. So I'm going to do the compass bearing of B from A is north 35 degrees east. So what does that mean? I start here at A and I'm going to go to B. What I'm going to do is I draw myself a little compass at the point A. I label my north. Okay. And north 35 degrees east. But which way is east? Never east, right? Okay, so east is here. And I'm going to go 35 degrees, starting at north, come over 35 degrees. And then I draw a line, straight line, up to here, and there is B. And that's how I do the first one. Conversely, it says here the compass bearing of A from B. So of A from B, so I start at B and I'm going to go to A. So again, I draw out my little compass here with the little center there at B. South 35 degrees west. Oh, so here I start south, so here I am south, and I'm going to start and I go 35 degrees to the west. And that's how you draw these. Okay? So how is that different here? Okay. Well, the other type of bearing is what's called true bearing. True bearing uses 360 degrees. It doesn't use north, south, east, or west. The big difference that we're used to is where it starts from. So in true bearing, all bearings are measured from the north in a clockwise direction. And a 3-digit number is used to represent the integral part of the bearing. So what does that mean? So again, if I start my picture here, I'm going from A to B. So again, I start here with A. This time I draw my little directional at A. So here's A. I draw the directional on it. And I want to go 35 degrees. So what does that mean? So again, 35 degrees means I start here on the north side. So again, I label it north. If you want, even put a little arrow. And I start here and I measure out 35 degrees. And I go all the way up here. And there's B. Now again, from B to A, if I was going to describe from B to A, I go here. Again, put my cross here. And they say it's 215 degrees. Wow. So that means here I go 180 degrees is here. Another 35 is here. There's my 215 degrees. I always start at the north. Okay, and there I am. It's like, great. Why do I need to know this? Excellent. for word problems. All right. But before we get there, I want you to practice, or we're going to practice together on drawing these out ourselves. Okay. So here we go. So it says here, when a single angle is given, I want to go the bearing from A to C is 30 degrees. Again, technically, this should be 030. So, again, so I start here at A. This I need you to draw with me, right? Start here at A. I get out my little bearing, or make a little chart. 30 degrees. Again, 30 degrees measured from the north. So I start here at north, and I measure 30 degrees. It's about 30 degrees, right? There's 90 degrees. It's about a third of the way. I get out a straight line, or as best I can. And I go out here. I make sure to label that 30 degrees. I come up here, and there's point C. Someplace out there. There's my bearing. Huh. That's not too hard, is it? So let's take a look at the other system, like I said, and see how that's a little bit different here. So this time they start up here with A. And I'm going to go ahead and get my little piece out saying here for directions. And they're saying from A to C is south 52 degrees east. So here I am south from my point. I'm going to go 52 degrees to the east. Well, again, never eat shredded wheat or never eat sour watermelons. However you chose to remember it. Here's east, right? So I'm going to go 52 degrees this way. It's about 52 degrees. Maybe a little bit more. And I draw my line. And there's where C's at. Okay. Your turn to practice. So off to the right-hand side there, you have 3 things to practice on. Ooh, I just caught something. This should be a 0, okay? So 032 degrees, bearing of 304 degrees, and north 42 degrees east, okay? I want you to use points A to C, B to D, and let's see here, G to H, okay? I want you to write something like that, so we'll figure this out. And on the flip side, you'll get answers. So go ahead and pause me now. Go ahead and do that now. Pause, pause, pause. Boom. There are your answers. Okay. Wow. Hopefully yours came out something similar. If you are having problems, this is where you need to let me know, first thing tomorrow. All right. So let's go ahead and see what's next. These are the big, meaty problems. All right, so you have 2 things, in your space. I'm going to ask that you're going to need some space to do a drawing here. So at least half your space needs to be this drawing, is what I ask, because drawing on these things is very important. All right. So let's first talk about this. Let's read this here. Ship travels 70 kilometers on a bearing of 27 degrees. Again, it should be 027 degrees. And then travels on a bearing of 147 degrees for 180 kilometers. Find the distance of the end of the trip from the starting point. Whew. So let's start working this out. So since the starting point, end point, I'm going to start here with S for start. There's my point. Boom. And it says I'm on a bearing of 027 degrees. So bring out my little thing. 027 degrees. That means this right here is 27 degrees. Okay. I go out for 70 kilometers. And I draw a point. Bink. And then I travel on a bearing of 147 degrees for 180 kilometers. So I get on another one. Make another point. Now I do 147 degrees. So it's more than 90, but less than 180. So someplace about there. Maybe a little bit further. And then I go like this. And that's 147 degrees. And I go for 180 kilometers. All right. And there's my end point. Go ahead. And I want to find that distance there. And like when I first looked at this problem, I was like, I don't know. I'm not sure if I could pull this off. And then I saw something. What's really great about bearings is this piece here. When I draw this line here, my north and south lines, there's my north and south, they're always parallel. And so I'm going to reach this way back in time, back to geometry, 2 whole years ago. And this north line and this north-south line are parallel, and they're being cut by this transversal of this boat being, moving on there, okay? So what does that mean? This is where you break out that old one is alternate interior angles are going to be the same. What? That means the angle on this outside piece here is the same as this piece here is 27 degrees. And that's something that you're going to have to put away in your little head and think about. If they give you something that's like, I don't know, because they give you outside degrees, they don't give me inside of the triangle, I don't have anything to work with here. You need to be thinking about, oh, wait, these are always going to be parallel, and these opposite interior angles are going to be the same, so that's 27 degrees. That's great, but I'm still missing this little piece right here. How can I get just this little piece right here? Well, I know this is 147 degrees. I know a whole thing is 180 degrees. So that means that this angle right here is 33 degrees. So I have 33 degrees and 27 degrees. That means that this whole piece right here is 60 degrees. And now I have a side, I have an angle, and I have a side. Side angle side, law of cosines. So with law of cosines, I'm trying to find this side over here. That's what will give me my x squared is equal to 70 squared plus 180 squared minus 2 times a, which is 70, times b, 180 squared, times cosine of 60. I go ahead and break out my handy dandy calculator, and I find out that x squared is going to be equal to 24,700. I take the square root of that. X is going to be equal to 157.16 kilometers. Wow. It's a lot of work. So not only do you have to draw things, but you have to remember things from geometry. All right? Let that one soak in for a little bit. Take all the steps I put in there. And let's go on to the next one. Finally, this one here has got 2 lighthouses. They're on a north-south line. From lighthouse A, the bearing of a ship is 3,742 meters away, is 129 degrees. Guess what? I don't want to deal with minutes. I just go 129 degrees. From lighthouse B, the bearing of the ship is 39 degrees. Don't worry about the minutes. Find the distance between the 2 lighthouses. All right, so here we go. I'm going to start off with A. And they say A and B are on north-south lines. So there's that. There's B. A, 129 degrees. So again, put my mark. Start at the north line. 129 degrees. There's 90. There we go. I'll call that 129 degrees. And that'll be about 70. And let's see here. So I just put that line out there. Next to say from Lighthouse B, the bearing of the ship is 39 degrees. So again, north-south line, 39 degrees. I'll go ahead and put that there. And this one right here, they say is 3742 meters. Notice that my line here that I first made is a little bit longer. Okay, and that's because I just didn't know where this 39 degrees, how it would look. So there we go. And so I just kind of draw it and I erase it. That's 3,742 meters right there. And so what is that? That is my ship. So you can go ahead and make yourself a little ship. There's my ship. Okay, maybe make a little sail. There you go. All right. Find the distance between the two lighthouses, A and B. So they want me to find this distance right here. Whew. Well, this is where, again, we got to remember, hey, from my north-south line here, this whole thing's 180 degrees. All right? So this means that this right here is 51 degrees. Well, shoot. This is 51. We have this triangle business again. That's 51. That's 39. Hey, 51 plus 39, that's equal to 90. And then if I know there's 180 degrees in a total circle minus the 90 degrees I just got, it means there's 90 degrees left over. It means, hey, this happens to be a right angle, which it actually kind of looks like one. So there's my 90 degrees. And so what am I given here? I'm given an angle, side, angle. Angle, side, angle. Angle, side, angle. Oh, that's law of sines to find this out. Oh, well, angle, side, angle, law of sines. So that means that, hey, so these two are related. So sine of 39 degrees over 3,742 meters is equal to, well, sine of 90 degrees time or over x. I cross multiply and divide. I find out that x is equal to 5,946. 5,096.096 meters. It's pretty amazing that you're able to get something so precise just off of off of two bearings and one rangefinder. I think it's amazingly cool. All right, you're able to find all that information out there, all from bearings. Now I know this is a little bit difficult. The biggest difficult part is drawing the picture and doing this stuff. We'll have some practice here for tomorrow, and we'll take it from there. Look forward to seeing you. Good luck. See you tomorrow.